All right, in chapter 1, the first definition that I use is the definition of statistics. So the definition of statistics is collecting, organizing, summarizing, and analyzing data. It's up to you whether you want to write these down or not. I will post it on Canvas or do something with it. So it's the science of collecting, organizing, summarizing, and analyzing data so we can see how data varies and maybe use it to predict what is happening. So I like to do this definition because this is our outline for the course. Like chapter 1 is collecting, chapter 2 is organizing, chapter 3 is summarizing. Then we kind of go into probability world for a minute, and then we come back and do the analyzing part. So this is kind of our outline for the class. So there's two different branches of statistics. They're descriptive and inferential. So descriptive is the collecting, organizing, and summarizing part. This is what you know. These are like words that you know, and I'm going to go ahead and say these. We don't talk about these until chapter 3, but like the mean, median, mode, those are all ways that we do descriptive statistics. Mean, median, and mode, or you talk about like pie charts or bar graphs. Those are all types of descriptive statistics. That's et cetera at the end there. But those are all types of descriptive statistics. So this is our collecting, organizing, and summarizing part of the class. We're describing a set of data when we are doing this. The inferential is the analyzing part. Okay, so what we are doing in the analyzing part is we are talking more about predicting. We are analyzing the data and predicting it to try to help us with future data or what will happen next. So the word there, inferential, is inference. That's an English word, but you hear a lot about that in like reading and stuff. But that means like to predict. You're making an inference about something in the future. So that is our analysis part where we are starting to predict there. So again, I will post these so you have these. I know my handwriting's not the best, so I try to say the words over and over again so you can read it well. But if I need to slow down or whatever, let me know and I can go back up. So some of the main words that we'll talk about here throughout the semester are these: population and sample. So it says we're interested in the average number of unit students in this class we were taking in spring of 2021. I guess I need to change that to spring of 2022. But the population versus sample. So we can't go ask all like 20,000 FSCJ students. Like that would make it too hard to do. I think there's more than that actually. It would make it too hard to do. So what we do instead of asking the entire population of FSCJ students is we go ask a small sample. Maybe we go ask 100 FSCJ students. How many credit hours are they taking this semester? And then take the average of that. And that's called a sample. We do a sample of the entire group. So the population here is the entire group. So when they are talking about population, they're going to use words like all. We want to know what is the average number of hours that all FSCJ students are taking. Okay, I want to know the entire group. Again, that's really, really hard to do because of trying to find all the students, trying to get them all to actually answer. It takes a lot of time and a lot of money, so it doesn't happen very often. The U.S. just did a census in 2020, right? So the census is when they try to get everybody in the U.S. to respond to the survey, and it's really, really hard to do, and it costs a lot of money. So like the U.S. only does it every 10 years. So the population is the entire group, and the sample is part of a group. The sample is part of a group. Okay. So what we have to do is we have to do small samples. We have to go ask 100 students or ask 1,000 students and try to use that information to predict that if we did go ask all the FSCJ students of the entire population of FSCJ students, what would happen? So that's where our analysis and prediction part comes from. We can't ever really know for sure because it just takes too much time and money to ask everybody. So we go ask a small part and try to use that data to guess what would happen for the entire part. Two key words off of population and sample is parameter and statistic. A statistic is, how do I say this? Numerical summary of a sample. Okay, a numerical summary of a sample. What does that mean? Okay, so if I go ask 100 FSCJ students how many hours they're taking this semester, and the average hours is 9, that is a statistic. Like I know for a fact that those 100 students average out to be 9 hours this semester. Okay, those are for sure numbers that we know. Like we know statistics for real. We did a numerical summary of a sample. Like we have a number to go with that sample. A parameter is our prediction about the population. So if our statistic is we randomly selected 100 FSCJ students, and their average credit hours is 9 that they're taking this semester. That's a statistic. But if I say, so we assume that if we were to ask all FSCJ students that their average hours would be somewhere around 9, that's a parameter. Because I'm kind of throwing it out there as, hey, it's going to be around this number. We're kind of taking a guess that if we were able to ask all of them, it would be about 9. So that's kind of the difference. Like statistic is a true number, and a parameter is more of a prediction. And the way you remember that is statistic, sample, SNS, prediction, parameter, P&P. But the main words that we will use a lot throughout the semester are population and sample. Those will jump back and forth, or we will see a bunch of those. All right, data. When we talk about data, there are different ways to separate it out. Oh, I forgot to change this word. And this word right here, Alex calls categorical, which I actually like better because it makes it easier for us to talk about. Categorical. So there's different, you can split the data into different words or different types. Okay, so categorical or qualitative data, Alex uses the word categorical. Categorical is where you can split the data into category or classifications. You can split the data into categories or classifications. So this is, I'm not going to write that, categories or classifications. So what's your favorite type of ice cream? I can put all the people who like vanilla over here, and all the people who like chocolate over here, and all the people who like Rocky Road over here, okay? Nationalities, okay? You can put the different nationalities in each group as you do those. You can't do a whole lot with categorical data. You can tell us how many is in each data and what percentage is in data, but there's not a lot of ways to separate that out. I'll come back to that in just a second. Quantitative data is a number that you can add or subtract, and it makes sense. Okay? A number that you can add or subtract, and it makes sense. Okay, so what do I mean by that? If I do how many minutes did it take you to get to campus? It took her 10 minutes, it took me 15 minutes, so it took 25 minutes together. It took me 5 minutes more than her. Your weights you can add or subtract, and it makes sense. Your credit hours, we were just talking about credit hours. She's taking 12, I'm taking 15, I'm taking 3 more, we're taking 27 total. So you can add or subtract those numbers, and those make sense. There are some numbers in real life that if we add or subtract, do not make sense. So those numbers in real life, and this is kind of your first example of how this, don't think like algebra, like statistics is a different branch of math. So this is not, don't think like I and the square root of -1 or things like that. Numbers in real life that you can add or subtract that do not make sense. So these are usually words. So categorical are usually words, but like your social security number. If I take her social security number and my social security number and add them up, it doesn't really give me anything, right? Or your phone number. If we add up each other's phone number, like that doesn't really give us a new number, right? Zip code. Okay, those are some examples of numbers that end up in the categorical section. So this is usually numbers. The quantitative are usually numbers, and the categorical is usually words. There's just a few exceptions. The Social Security is a classification of when you were born or when you got your Social Security number. Your phone number is a classification of where you got your phone. Your zip code is a classification of where you live. So you can put all the people in 32246 here and all the people in 32250 here. Like that is a number that actually ends up being categorical. So like I said, most of the time categorical is words and quantitative is numbers, but there are a few exceptions. Like I said, you can't do too much with categorical, but quantitative, they're numbers, so you can do a lot with them. So there's actually 2 more ways to break those down, and that is discrete and continuous. Discrete, you can count, and it is finite. continuous, you can measure, and is infinite. There's infinite possibilities, okay? So what do I mean by that? Count and measure's kind of the easiest way to do that, but I'll talk about the finite and infinite part too. You can count. If I want to see the number of cars in the parking lot, okay, we're doing a study on how many cars are in the parking lot on Monday, Tuesday, Wednesday, Thursday, Friday, like by average a day, we can go count all the cars in the parking lot, okay? If I want to know the average height of all my students, well, I'd have to measure you, okay? So the count the cars in the parking lot would be discrete. The measure how tall you are would be continuous. The reason it is finite and infinite work there is because if I go count the car, let's say I was doing a study on how many times y'all went to the beach last semester or last summer. Well, you can go to the beach 1 time, 2 times, 0 times, 3 times, right? You can't go to the beach 1.5 times. So there's like a finite amount of numbers that you can go to the beach. But if I was trying to measure you, your height, and I want to know how tall you are, I could say, hey, you're 6 foot tall, or you're 6 foot 0.5 inches tall, or you're 6 foot 0.57625 tall. Like if I measure you with a big ruler, I can't get that accurate. If I measure you with a better ruler, I can get more accurate. If I measure you with a laser, I can get extremely accurate. So it creates an infinite amount of variables. I think the easiest way I've seen this drawn out is discrete. You count. So you can count by like halves, like you can count things by like that. But I go 1, 2, 3. Whereas continuous is more like a straight number line. And I could be any variable in between 1 and 2, or any variable between 1 and 2 and 3. And that creates an infinite amount of variables. It doesn't mean you can be infinitely tall. It means between 6 foot and 6'1", there's an infinite amount of variables depending on how small the fractions go. But again, I don't think you have to really break down to the finite and infinite part of that very much. That's more algebraical and conceptually algebraic. The count and measure will work for you most of the time. The number of times you go to the beach, you count that. Okay. The amount of gallons of gas you put in your vehicle, like you have to measure that, like in gallons. All right, so we go do samples. We go do samples in class to collect data. So like chapter 1 is all about collecting. Okay, chapter 1 is all about collecting. So there are different ways to sample here. One word you will see in most of these ways to sample is random. Okay, random is a key word in statistics. Everything we need to do needs to be random, because if we don't, that leads to bias, which we'll talk about in just a second. But we need to create random data, collect random data, because if not, we're kind of messing with it some way. So a simple random sample is everyone has equal chance of being selected. Okay, this is the most common way to do it. This is the most accurate way to do it. Everyone has a random chance, equal chance of being selected. So I put all your student numbers, or put all your names in a hat, and I randomly pick them out. Or I randomly draw social security numbers and start calling them, or phone numbers and start calling them. The simple random sample is the most accurate way to do it. Everyone has an equal chance of being selected. A stratified random sample, what you do is you split it into groups. You split everybody into groups. So you may do like males and females. Or I could do, if I was doing this class, I could do the first row of people, the second row of people, and the third row of people. And then randomly select people from each group. Okay, randomly select people from each group. So like right here, I could say I'm going to pick 2 people from each row. So I do the first row and I pick 2 people. Then I do the second row and I pick 2 people. Then I do the third row and I pick 2 people. So you pick the same number of people from each group. You split it into groups and you randomly select from each group. A cluster random sample would be you split into groups and then randomly select the entire group. Okay, you randomly select the entire group. So again, I split you into rows of first, second, and third, and then I do a random number. I pick a random number between 1 and 3, and I get 2. So I ask everybody in the second row. Okay, So that's kind of the difference. The stratified, you split them into groups, and you randomly ask people from each group. The cluster, you split into groups, and you randomly ask the entire group. You randomly pick one of those groups and ask the entire group. Systematic sampling is every nth person. And again, I'm using people as examples here, but these could be objects, like if you're working on machines to see which one works and kind of things like that. A systematic is every nth person is the way you write that. I'm going to randomly pick every third person to answer this question. I'm going to randomly pick every fifth person. So that's why I put nth, because we don't know how many. Usually you pick a random number, 1 through 10, and you say, okay, I'm going to pick a randomly pick a number between 1 and 10, and I get 8. So I'm going to ask every 8th person. And then convenient sampling is you just do whatever is easily accessible. You do whatever is, oh, there's 2 S's in accessible. Whatever is easily accessible. This creates bias. So this is not a good way. Creates bias, not good. So if I was a manager at Publix and I was trying to figure out, do you like shopping at Publix where shopping is a pleasure? Well, yeah. If I'm asking people as they walk into Publix, then here I can pull it up. If I'm asking people as they walk into Publix, then they're going to say yes, like they like shopping at Publix because they're coming to shop at Publix. So you just do something that's easy instead of actually going out and randomly selecting people. If I wanted to survey all FSCJ students, I can't just ask everybody in my class. Like, I need to go to different classes and ask them. And the last thing here is, you've heard me say the word bias a few times. By the way, I guess before I end this section, these are different ways to sample. There's not one that's better than the other. Simple random is the most used one. But the best way to create good data is to do these over and over and over again, and maybe use different methods and kind of see, because then you're asking different people, doing different things, and you're creating good data. If I just do a simple random sample once in one setting, one time a year, different things, it's not the best data. Like, I should do it again at some point in time to kind of compare and see that. So that is our first type of data here, is sampling bias. So like when you ask a question, the wording of a question, okay? Those type of things create sampling bias. So like what I mean by when you ask a question, it's been a little cold this week. It was real cold on like Monday or Tuesday. I don't remember which day. So if I ask you what your favorite season of the year is right now, most of y'all say spring or summer. But if I ask you in August, in like the fall semester, what your favorite season of the year is, you're tired of summer and you say winter. So it's when you ask a question, like in the time of the year may matter. When you ask a question in a survey, like if I ask a super serious question, or let's say I ask a silly question and then ask a super serious question, I've kind of like changed your mindset from a silly question to a serious question. And like how you ask it in the order of a survey, you may lead people into answering it a different way. Wording of a question, again, you may lead people into answering it a different way if you word it poorly. So those are a couple ways of sampling bias. If you don't do random selection, like you got it, this is about sampling. So if it's not random, then that creates sampling bias. Voluntary response bias. A voluntary response bias is, how do I say this quickly? I think of it like this. Only people who are passionate will answer. So, you know, sometimes you're walking up to campus, or I don't know if you've seen it yet, but people will ask you a question or sign something or do something. Only the people that actually care about the issue are going to stop and sign it. So the people who, you know, maybe 50-50 aren't giving their input, and those are the people that you want. So only the people who choose to answer the question are going to answer it, and usually the people that choose to answer the question have a strong opinion one way or the other. So you're not getting an accurate depiction there. Response bias. Why did I just go completely blank on response bias? Non-response bias, I'll skip it. Non-response bias is not enough people answer. I'm sure it'll come to me in a second. Non-response bias, not enough people answer. So like telemarketers, they call 1,000 people a day. If only 2 people answer, and then they go to their boss and be like, hey, this many people answer this many people believe in this, and only 2 people answered. Well, if you call 1,000 and only 2 answer, you don't get good data. Like you got to have enough people answer the problem or over that. So you got to have enough people answer the question. Response bias is this one's kind of hard, but when you this is my fault. Wording of a question actually goes under this one. My bad. I can make mistakes too. Let me double check. I guess I got these mixed up a little bit, but all right. So response bias is like when you don't get a truthful answer. So the wording of the question would cause that. Like you may lead them into something. My bad. And I guess sampling bias when you ask a question would be there too. But convenient sampling. This is an example of convenient sampling. You do what's easy. How you sample. How you're sampling is messing up here. I guess I should have looked at the kind of a duh there. How you're sampling is what creates sampling bias. Response bias is when you're leading them to something, so they get an untruthful answer. My bad. It's early for me to do math too.